Welcome in, everybody. Hope you're all doing well this evening. Hi. I'm glad you like that, Carrot. Glad you liked that. That's good. The camera's fixed. Let's make sure everything is all happy. Andrea, Sandy, Dermo, welcome in. Carrot, 12 months of being stuck with me. Man, if you had to deal with more than 12 months of this, I don't know what you would do. I want to pull up the stats on how much the excited carrot emote has been used at this point now. It's also almost like Toby knows that me talking to my... he has been trained at this point to come here whenever I start stream. Hey, up. Up, 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 up. Hey, up. Come here. Up. Toby. Up. Yeah, there you go. Yeah, hi, bud. Oh, you're gonna go sniffing? You're gonna go sniffing? Okay. Yeah. Oh, there you are, bud. Hi. Hi, bud. Oh, my melty boy. 111 months. Is that the actual number, Carrot? Jeez. It's such a satisfying number. Yeah, there you go, bud. Alright, bud. Alright, go have fun. Alright. That is a very satisfying number. That's fantastic. Yeah, so today we're going to be doing some stuff on the printer. I'm hoping we'll eventually replace this guy. So the first piece is 3,402 days. We missed our 3,400th day. Darn! What we need is the 3443, so we have the palindromic number. Yeah, I would say that's fair. I generally go from July 4th. That's usually where I go from. All right. So, yeah, stuff is going on. Drunk Beavers got their stuff together. I checked the shipping notification on Monday. I was like, oh, we might actually be there. Yeah, see, that doesn't run off the tongue quite as well. 4,898,464 minutes. Grace, thank you so much. Thank you for the 12-month resub. Hey, Tech, welcome in. Welcome in. I hope everybody's doing well this evening. 8 minutes late. How dare you? Yeah, our board came in, which is super exciting. I'm really pleased. They, as always, I mean, the board house always does such a nice job. This is the first non-square board I've done, and I gotta say, overall, not bad at all. Not bad at all. You can see where the router started and stopped its pass. There's a little skip there, but I accept my detention. Your punishment is to study for my next test. I mean, it's only robotics and automation, you know. It's only like multiplying 5 6x6 matrices together in a row, and then solving the subsequent system of equations. I mean, it's like nothing really. So if I flip over her, it is, Carrot. It sure is. Oop. Oh, so, well, there you go. There's the Danny merch. Maths, what did I tune into? Because Carrot won all of the giveaways the other day. Didn't leave any giveaways for anybody else. I'm sorry, Azili. I'm sorry for punishing you with math.
punishing with math. Oh, there it is.
Do you have finished click-clacks?
I do have finished click-clacks.
Bring the finished click-clacks here. Yeah, click-clacks.
Yeah, click-clack.
Yeah, click-clack. Yes.
Oh, hi there.
Oh, hi there. These are very pretty.
There. Oh, hi.
Oh. Carrot and Dunder do win everything, don't they? No, Carrot and not Dunder. Yeah, these are really lovely. They've got this really nice like strandy flake through them, and yeah, that's super pretty.
You know what? I hadn't won anything in a really long time, so I felt like I was overdue. Yeah, that's how you do it.
Not Dunder and Dunder mug, right?
I have not come up with a name for this yet. I can't lie. I'm missing there.
That's
there
gonna
it is.
get polished.
Yeah, I was gonna say I'm like this set. I actually feel like
I don't know if that actually ever got to the polishing phase, did it?
You told me it was done.
Okay, it looks like it has been.
Yeah, you told
One
me.
or two faces looks like they got missed though.
Yeah, I don't have a name for those yet. What do you guys want to call those ones? The really super shiny, ridiculous ones. Like, because it kind of, honestly, it kind of reminds me of like going fishing, like a little bit.
They remind me of grass clippings that you can actually
Shiny grass.
shiny not sneezy.
Yeah. I like big destiny candy.
Yeah, gotta be careful calling something grass on the internet though. But yeah, so this is our lovely little board. You can see our prompts up till now on it there.
The fluffiest boy in the
And
world.
there we are. So what we're gonna do today is we're gonna populate this board, but we're gonna do it in a really fun way. So first of all, I'm gonna lay out the board, and that's gonna be a thing. But then you all get to see a tool, a toy tool that you haven't seen before. Rip, which is this little guy over here. And that's my surface mount soldering reflow plate that I designed last year. Shoop. Which allows me to run a PCB through a soldering curve without a whole ton of effort. So, oh boy. Did you know that the cable from that webcam can hit my buttons? I guess the webcam says we're done. I mean, I need a nap, so that's fine. That's fine. Looks like the camping stove that I had to share with 3 other people when I supplemented uni. That's what it started from. Oh wow, Q drop, raid, sub raid. Yeah, no, that's a whole bunch of stuff. Well, get your drops in. So that was actually built from a standard hot plate. It absolutely was. Basically, it is a hot plate I got from Value Village with a bunch of electronics strapped to it to make it actually hold a temperature really closely. Now, the thing that's a little annoying about it, and we'll see, maybe you can tell me if this is as bad as I think it is on your end. I go here and I go there. How bad is the light flickering for you? Because this is what it's going to look like pretty much the whole time I'm actually soldering with it. I don't know if that's a problem for you. For me, it's a little annoying, but I can tolerate it. But I want to make sure that it's like not going to completely drive anybody nuts. But yeah. All right, get your drops in. We're dropping, for you it's not great, but you know how I feel about flick relight, yeah. Last call for drops. Last call for drops. Because I don't want to forget the thing. I'm actually going to update my Q drop button to just automatically start the drop on an interval. Otherwise, I'm going to forget it, and it's going to go like 15 minutes without me doing anything. So we're going to do the bip buttons. Oh, look at that zoom. Can we get a drive back? Oh, Grace has got a bit of pinball, but we're not. I don't think any of us are getting anywhere near where we need to. Nope. Whatever. How dare. Right? You know what? Actually, let's do... Nope. That's very much the wrong application. Guess who was looking at their character sheet before they started stream? Oh well. Let's just do this real quick. So if we go in here, go inside the Q drop, and then we add a utility. And I believe there is a wait. Where is it? Oh. Numbers, text variables? Nope, that's the wrong field. Ermin. Yeah, I was looking at Ermin. Let's see. It is a Witchlight week. It is. Ah, there it is. Wait for timeout. Timeout after some milliseconds. Let's say, 60 seconds? Sound good? $60,000. And then we can go copy, paste, start drop. And that should do the thing. You do get to dress like a cow on... You do get to dress like a cow person on Sunday. Okay, so that should... Now that should mean if I hit Q drop, we should now have, in 60 seconds, that should automatically start the drop. Should being the operative word. Alright, so, for anybody that's not familiar, which I'm assuming is probably most people, with how soldering works, both at a low level and a high level. So, what we mostly do on stream is what's called through-hole soldering. And that's dealing with these guys here. So, you have some kind of pin. Yep. So you have some kind of pin in some kind of hole, like that. And then you apply heat to the pin, and you apply heat to the pad, and then you flow solder in. Dermobot did save the day. Dermobot is fantastic. Dermo is twice as fantastic as Dermobot ever hopes to be, though. Oh no. Oh, we got a raid. Artist explores the world. Welcome in. I was wondering, I'm like, why did my scene change? Because I set it to. I think this is the first time with the new setup. So, welcome in. How you doing? I hope everybody's doing well. Thank you so much for coming in. I see a familiar name there. Welcome in, Oz. Codely, Artist Explores the World. Thank you so much. Thank you for bringing your friends over here. I'm Cole. I do engineering, 3D printing, electronics, leatherwork, mini painting, and just about anything that my nerdy little heart desires. Today, we are working on this guy. So at the start of the month, we started the month of making and basically made a little roll list. And we rolled a whole bunch of stuff, and we came up with the prompts that I had to integrate, which was leather as a material, reflow plate as a tool, woven as a technique, humidity. Codely, thank you for the follow. Thank you so much. So here for the mixed media vibes. I mean, why stick yourself in a single category, right? This is so fantastic. Thank you so much. I'm gonna have to click over. I'm gonna drop a follow there so I can check your stream out after I'm all done. Yeah, we needed something that reacts to humidity, a theme of weird science, a theme of cursed, a tool of handsaw. I don't know how handsaw is going to factor into this yet. We're going to figure it out. But we designed this little circuit board on stream. So what we ended up coming up with the idea was making a little amulet that reacted to humidity and temperature, and that displays it like a clock. Stream was excellent. It was the last day before I take a vacation, so I tested out some new supplies and did some giveaways. Oh, that sounds lovely. That sounds absolutely lovely. So, what we're going to be doing today, as these just came in, before we can actually program this thing, we need to get it all put together. So, we've got my little solder paste dispenser here. And, pardon me. I was just talking about how this stuff works. So normally we do through-hole soldering, which is like this. And it actually physically goes through the board and you solder on the backside. Surface mount soldering does exactly what it sounds like. It mounts on the surface and we go from there. So in order to achieve that, what we do is we can still solder it similarly. Hey, my good Zimber! Hi! Bip. What kind of CNC machine is that? Are you talking about the camera that you're... this guy here? That is my 3D printer. It is a Robo 3D R1 Plus with some significant and very extensive modifications over the last 8 years that I've had it. I've got that printer there. Right beside it, you can see the little red box. That's my resin printer. We also have a little tiny baby printer that's down under here that you can't see, and a generic CNC platform that I still need to finish tuning in, but we just haven't gotten around to do that because we are in the throes of the semester right now. Final year, midterms, projects, assignments, way too many things to talk about. But yeah, we're doing all the fun stuff. So currently today, what we are doing, and let me flip over here for a moment. I will switch this to Prusa Slicer. So this is what's currently on the printer right now. It's a number of pieces that somebody else made. I need more projects. Absolutely do. Currently, we have this camera up here. The mount isn't great. It's not terrible, but it's also not amazing. Work with the laser cutter, mostly wood, but the 3D printing is fascinating. I want to try it so bad. And you know, I want to do the other side, but I need a spot with slightly better ventilation. Once we get my workshop finished wiring up, I'll be able to kind of look at some of that side a little bit more. More specifically, once I graduate and the drop didn't start, well, that's okay. We'll figure it out. Yeah, setting up a laser cutter is definitely something I want to do. I know I have access to them. Rigged! I know I have access to them at the university right now, but, you know, it's just an interesting tool set. Yeah. Preemptive rigged call worked. Alright, so here's what we're going to be doing. For the moment, we're going to set this guy up. What we have is we have our solder paste here. So instead of when we're doing, knock the camera over. When we're doing through-hole soldering, we normally use wire solder. This is flux core solder. It has, it's metal, and then it has a very actually tiny little hole that runs all the way through it that's filled with flux, which is a type of acid. And when you make it hot, that runs the flux onto the pad, strips away the oxidization, and allows the metal to make a good bond. Now, this is really great for working with our hands because, you know, we can manipulate a wire and we can use that just fine, right? Doesn't work super great for surface mount. You can surface mount solder components by hand for surface mount, which is what we're going to be doing on the back of the board, and this was very much an intentional decision. I probably could have fit the voltage regulators up here, but I was trying to minimize our total profile, and I already knew I needed some stuff on the backboard anyways, so yeah, it's very satisfying. I would say it's more closer to like a hydrophilic material where it really just kind of wicks in and covers everything. So this is our this is solder paste. This has basically, I've got a little 3D printed thing on here, but went to grab a thing to squeeze some solder out on so you could see, and put my fingers in the solder that I put out in there earlier. So it works similar to like a caulking gun, where you put a little pressure on the plunger, and right now I need to get the little syringe tip here full of solder. There we go. So this is what we're working with. So now our goal is go along across the board and put little blobs of this stuff everywhere I need it. If one of the options that was available to me, and what we'll usually do if we're going to be doing kind of more than one of these, or it's a really particularly complicated board. So I'd done this board previously, and then I designed this little solder paste stencil that goes over the top of the board if I put it in the correct orientation. And basically, when I snap that in there, it sits in there nice and well. And you see that all we have left exposed is all the metal. So I just put a line of solder paste on here and then drag it across and then pop the board out, and then I can place all my components. In this instance, I just didn't feel like it. Taking the time to actually pull everything together and do the 3D printing of this. These are a little fiddly. You can pay to have them done, but usually it's an extra like $10 for a laser cut stencil. And well, I just wasn't willing to invest that in this project. So this is what we're going to do. We're going to basically come in and we're going to put a little bit of solder. And we'll see how friendly this is going to be. This solder is not as new as it probably should be. So that means the flux components are a little bit, see, that there is way too much. This is not enough. So we're going to be fighting with our solder a little bit, but the nice thing with surface mount is when this stuff reflows, it actually goes liquid. This board is for a super bizarre little project. So at the there's our thing. So at the start of the month, we made this, which was basically our own maker version of Inktober or Promptober or whatever you want to use. We're using Promptober out here, but we basically started with this table and then rolled on the material, tool, technique, feature, and theme, and then a couple of people redeemed some additional stuff So what we currently have is, for a material, we have leather. We have Reflow plate as a tool, which is off screen here. Woven as a technique. Humidity as a feature, so it has to react to humidity in some way. Weird Science and Cursed as themes. And then handsaw as another tool. So, a little bit odd. I'm not sure how handsaw is going to fit in yet. Really not. But we're going to figure it out. So what we ended up coming up with, after some discussion, was basically this. Which is to say, we're going to make a little amulet. A cursed amulet, that is. Which shows the current temperature and humidity through a set of... a pair of LED rings. So that's what you can see here, the outer ring and then the inner ring. One is going to display humidity and then one is going to display temperature. This is very firmly in the category of stuff that never would exist without this prompt challenge. So it's an interesting one. It's definitely a unique project. Unlike anything I've ever worked on before. It's one of the more complicated boards I've had to work on, as far as managing the overall routing. And what we're going to do is we're going to go around, we're going to populate all of these pads with solder paste, and then we're going to walk around the board with all of the components and place those in their spots. And once all the components are placed, then we can run the whole thing on the Reflow plate. And we're probably going to have to deal with a couple of spots that want to flow into each other. I'm thinking specifically issues like right here, where these guys are kind of close. But we'll see. The big thing we're relying on here, and what kind of allows this whole process to work, is surface tension. And it's a really interesting little process, but basically how this whole thing works is we heat the board up. So we're actually going to heat the entire board up rather than just a single pad, which is, again, usually what we do with through-hole soldering. And then from there, what we're going to do is you heat the whole board up, and that turns the solder liquid, melts the flux, and then the components that we have literally float on the bed of solder. And as they float there, it allows them to line up with the pads. It allows the solder to kind of suck to its own little spot without running over onto everything else. And it allows all the components to self-align and all this other kind of fun stuff. And it really looks like a really weird magic trick. And it's kind of cool. And I am a big fan of it. And I designed this board, the tool that we're going to use here, I designed this last year for a class that I took. Not specifically that I needed the tool for the class, but specifically I used the class to make the tool, because I knew I wanted it. And then I really haven't used it since. Because, you know, that's how life works, right? And I think that's all of the pads. All right, cool. So there is all of our pads with a little bit of solder on them. Let's put a little bit more on that guy. By trying to put a little extra on that one, I ended up taking it off. That's always fun. There we go. All right, cool. So there we go. Try and keep this whole thing in focus as much as I can. So now what we have to fight with is, there's our capacitors that we're going to be dealing with. And then we have our LEDs that we're going to be dealing with. And for the other side of the board, what we're going to be dealing with by hand is our little voltage regulators. But for the time being, we only need to deal with these. And specifically, what we have, let me get this in focus here. Alright. In focus, please. Where my hand is in focus. Alright, you see down in the bottom right corner how that edge is. Oop, how that edge is actually notched. Oh, jeez. I am just trying my best to lose this component. That edge is notched because that indicates the ground pin. So this has a very specific orientation it needs to go on. And part of the problem that I'm going to have to go around and clean up is that in some of these instances, I actually ended up covering up my pin marking orientation. So I've got to make sure that I can actually see what way around all of these pins are going. It's pretty consistent across the rest of the board, but we do have a couple of weird pins because of just the way we did it. Component drop. Alright, so let's start by dropping some LEDs on here. So how this works, so whoop, whoop, look in here. So we literally just take this and we set it there, and we give it a little nudge so it kind of, think about like laying bricks where you might kind of nudge the put the brick into some mortar. Similar kind of concept in this instance where, you know, you can see the component doesn't come off because it's stuck in the that. So we're just going to go around and make sure that we have the correct polarity for everything. And we're not going to stress too much about getting these perfectly straight because, as I said before, this whole thing is going to be self-aligning once we have it flowing. And then we got to go around and put a matching capacitor for every LED that we have here. And don't you worry, I've specifically got the camera in a way that I'll be able to move it over for you, so you'll be actually able to watch the reflow, which is kind of hilarious because the first chunk of it, nothing happens, and it's really boring. And then all at once, everything kind of moves, resettles, reshifts, and otherwise positions itself. And it's really wild to look at for 15 seconds, and then the whole thing is done. There we go. There's one strip of LED tape done. Let's grab a second strip of LED of our LEDs. These ones are kind of interesting because they actually come with a desiccant and a humidity indicator in package. And I actually think I am missing one row of LEDs because there's supposed to be 2 in one pack. And I just went through one rail, and I don't have a second pack right here. So the question is, where did I put it? Not there. Well, that's okay. I ordered extras. I ordered extras for a reason. That being one of the reasons. Yeah, rails, strip, however you want to call it. There's different... So one thing you'll notice about this is you see how there's all these little holes along the side? These are actually designed for both manufacture, but also so you could feed this as a strip into what's referred to as a pick and place machine. So you basically tell it what everything is up, and the pick and place machine goes through and does exactly what I'm doing right now. Should we actually add component drop? I mean, we shouldn't have to, but if I'm going to be doing much surface mount work, it might be worthwhile. So surface mount work, it's only a matter of time until you screw up and drop something. Tweezers are really not optional when you're doing surface mount work as well. Like, you have to get yourself some good non-magnetic, ideally ESD safe. I do not have a pick and place. God, no. No. I'm saying that the way these strips are arranged with the little holes and everything are so you can feed them into a pick and place machine, and they would do what we do, what we are doing right now. God, no. I do not do anywhere near enough board design to justify... yeah, honestly, just the magnifying headsets, or just honestly any kind of magnifying. I've got 2 or 3 magnifying glasses, and then I also have a USB microscope that I pulled out on stream once or twice, which is really good when you're dealing with super small components. So like, let's talk about. So they're specified by their millimeter sizing. So this is a 1208 resistor. Which is 12 meters long, 8 millimeters wide, I believe. Or it's mils. I don't know. It's either mils or millimeters, and I can never remember. But, so this is a 1208. That's kind of a standard hand solder size component. Then you get into smaller components, like these guys. And these are 0603s. So you can see compared to the resistor, they're, you know, about half the size. I'm really happy, Carrot. I know your Streamfest is going to be ridiculous, and I'm so excited for it. And then you get even tinier. I'm trying to remember what the size on these ones is. I think it's an 0102. And I actually did hand 602. Yeah, exactly. 602 best size. Hold on, I'd have to actually look that up. Yeah, these guys are just entirely too tiny though. Like, I had to hand solder this once, and it was wholly, unfortunately, horrible. Let me just... Why am I looking this up? I literally have a ruler here for this. I'm trying to Google it and get an understanding, but I literally have a ruler here for this specific purpose of understanding the sizing of these pieces. So we go over to resistors. Yeah, so the ones Dermo's talking about would be these guys down here. Personally, I like my 0805s. 1206 is honestly getting like a little ridiculous. You don't like, people say that this is like, want that. 1206 is, yeah, that's way too big. 0805 I don't mind though. 0805 is actually pretty decent to solder by hand. Oh yeah. Yeah, 0603 I work with. I've got resistors and capacitors and LEDs in that size. I believe the other ones that I just showed was an 0402, and that was just absurdly tiny and really fiddly to work with. And then you can get even smaller, which, like this guy here, You can see that's an 0201, which go away. That's awful. Yeah, I really like this ruler. It's a knockoff of one that was made by a better company, but it's basically a whole bunch of different footprints and pitches and traces and conversion tables and footprints for different categories of different pieces. Shows you how to size your inductors. Yeah, it's a whole thing. All right, so we have now placed our LEDs. Now we're going to grab our capacitors. Well, I didn't actually, on that note, I don't know how, I know the people here are nerdy enough to probably know. Are you aware of paper towns? Because making small errors to avoid copyright is actually a thing. Was never able to use magnifying glasses. Yeah, I use my USB microscope mostly when I'm doing that kind of stuff. And then I've also got to swap the tip on my soldering iron to something a little smaller. Because most of what, like I said, most of what I do is through hole, but I've been doing a lot of surface mount lately. Which I don't mind. I actually enjoy surface mount. It makes for satisfying projects. But yeah, I don't know. Are people aware of the concept of paper towns? Because those are super interesting and kind of make me laugh every time. So for anybody that's not familiar, because I'm assuming somebody in chat has heard of a paper town, but what a paper town is basically something like a PCB layout, for instance, to say that you didn't know or you didn't copy somebody else's design is really hard because there's 1,000 different ways to show the exact to make the exact same circuit, right? Even if it just comes down to like the distance you put the traces apart, whatever. However, something that you don't have that luxury is maps. Now, as you can imagine, a map is meant to describe a geographic location and the, resulting spacing and such between them. It also costs a lot of money to survey the area, generate a map and everything, especially back, well before computers. So, to prevent other companies from taking their maps and just reprinting them, because you couldn't say, hey, if it's a fully accurate map, you can't actually point at it and say, hey, you copied my stuff. So what they would do is they would put traps in their maps. There would be tiny little town names and roads and intersections that didn't exist. So, now what's kind of funny about that is that while this is a great practice and it works and it did a fantastic job, there is actually instances where enough people were going to these paper town places of like, I've never seen that before, and showing up, that there is actually a couple of instances now where paper towns became real towns, and the paper towns stopped functioning as a copyright infringement tool because the place actually existed now. So, there you go. Okay, we're just gonna... Yeah, these trays are a little smaller. Alright, we're just gonna knock some out on the table for now. Now, surface mount capacitors are kind of weird. Because they're these little beige blobs with 2 metal strips on them. And there are no markings on them at all. So, surface mount resistors, on the other hand, you can see have a little printing on them. In this instance, this one says 6800. And that you can use to find the value. In this instance, it's 680 with 0 additional zeros, so it's a 680 ohm resistor. Easy enough. With the surface mount capacitors, there is no markings on them whatsoever in any way, shape, or form. So, either you know what they are coming off the strip because you were the one that specified what should be on the strip, or you measure them, or you just go close enough, screw it, I don't care. In this instance, this kind of fits a bit of both, all three, because I know what size these are, but it also doesn't really matter. These are 0.1 microfarad. These are filter caps. These capacitors could realistically be one of very many sizes, without any issues. These are just basically meant to stabilize the incoming power. That's it. That is all these are for. So we have our voltage regulator, which also has output capacitors, smoothing capacitors on it. So a capacitor, the way I've always liked to think about it is if we have the analogy of water. So you'll oftentimes hear people talk about electronics with respect to water. So, you know, if you think about a wire like a garden hose, the amount of water pressure is your voltage, and the amount of physical water flowing through is your current. And then a constriction in the hose is a resistor. However, with that framework, what in the world is a capacitor, right? Doesn't really make sense in that framework anymore. So, it's fine though, because what it actually is a bucket. It is a bucket that allows you to fill it up a little bit as you're going, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8. All right, cool. I can dump all those ones. I like to think about it as basically like a bucket in the system. So what it allows you to do is if your pressure is fluctuating up and down, putting a bucket in the system basically means, so if you have your hose empty into a bucket and then a hose coming off of the bucket, that basically means that the pressure fluctuations from that original source are not going to be as big of a problem, right? Johnsy. Now, we've already got a couple of these. However, the manufacturer specification told me that I should have a filter cap on the power line right by the chip. Now, these are high-speed digital devices, so as a result, they're oftentimes a little bit more sensitive to voltage fluctuations than other devices might be. As a result, we have a whole bunch of extra capacitors that we are placing on here that might not otherwise be here. Like, if these were just regular LEDs, we wouldn't be bothering with these. These wouldn't be required. But because these actually have their own little processor on board that needs to figure out what's going on, no water in that potion, apparently. In that clear milk. 1, 2, 3, 4. I don't know the lore behind clear milk, but it does feel very Johnsy. Come on. Now, there is a decent chance that we're going to have to rework one or two of these components once this is actually all done. However, we're just going to go through pad by pad, make sure that everything is all populated. Albatross, welcome in, friend. How are you doing this evening? We're doing electronic shenanigans tonight. All right, we have Make sure that one's closer over there. And then nudge. The big thing is these can be a little off axis, but if they're too far off, they'll actually fully just turn sideways and screw themselves over. Especially on these, because specifically for the capacitors, I chose the hand solder pads in case I needed to hand solder these, as it were. And yeah, I think we look okay here. Just get rid of that extra solder there. All right, so it is time to move the camera. So what we're gonna do, rip. You'll be able to see my little device there. Yeah, the moth on the board, the moth on the dice, all of that piece. So if I grab this, nope, that actually doesn't even need to be a source. Go away. Plain Logitech. Transform. Flip vertical. Flip horizontal. Ta-da! So this is my little reflow plate that I made. And what it allows me to do is I can go in here and I can tell it to fix at a certain temperature. So if I have a process that I just need to hold it, if I'm trying to get loosen some thermoset adhesive or something like that, I can set my appropriate temperature, turn it on, and it'll just hold that temperature. I can pick through a number of predefined solder profiles. I can also come in and just say, hey, here's all the set points I want. I want my preheat temp to be a little bit higher, my peak temp to be a little lower, whatever the case is. So in this instance, this is the solder we're actually using. So a preheat temp of 150 degrees Celsius, a peak temp of 250, ramp temp of 150, preheat time. So we have a couple of temperatures and we have a couple of times. So basically it's going to sit at 150, let the board and the components and everything up to heat, and then it's going to spike up to 250, stay there for 40 seconds, and then start cooling down. And that is going to be the panel that we use. So let me flip you back to the way you were. Shift you back a bit. Throw the camera on the floor. We are going to try our best to keep this whole thing in focus so you can enjoy that whole process. Gonna make sure I have the right reflow profile on. Right, profile 1. And start. So this whole process is gonna take about 6-7 minutes. So for the time being, it's not really gonna look like a whole lot is going on over there. Because realistically, there's really not a whole lot going on over there. That's just the reality of it, right? But we will have the opportunity, and I did actually get spares of the NeoPixels, so I'll be able to have some fun with those on another project, if I so desire. Which, generally speaking, I probably will, because they're a really interesting little piece, and having addressable LEDs is really nice, because otherwise driving LEDs is a little bit of an annoyance. So what you should be able to see by now is you can see that the solder is spreading out. You see it's kind of flattened out a little bit, and it's kind of mooshed all over the place. Right now we are coming up to 120 degrees. And we're getting into the point where the fluxes are going to start activating, and basically the viscosity of this solder goes really way down. And that's actually a really good thing for us, because what that does is it means it covers the entire pad and gets underneath the components and makes sure that it's all kind of flowing across all of those surfaces. Then it's about to, we're about to hit our soaking set point, which this thing is going to smoke like a bugger because there's some adhesive and stuff on it right now, but not much I can do about that. There's just a little bit of grease on there, which is unfortunate, but that's fine. Yes. So it's in the soak period now, which basically means it's going to just sit there and hold the temperature, because we want to make sure that the whole board and the components and everything are all up to temperature, because if we just try and get the board up and going, we'll end up with a whole bunch of cold shuts and really bad crystallized solder joints. So yeah, right now we're in our soak period. We're about halfway through there. One of the things that I'm actually really proud of for this is that I have a live plot of the temperature curve, which I'm very pleased that I managed to figure out. That took entirely too much time to figure out. Part of that was actually really annoying, was the people who made the library for the touchscreen that I used. They did a really stupid thing. So it is an LCD with touchscreen, right? And it actually doubles up on some of the pins as far as what they are. So basically you send a signal down the pins for an output and tell the controller, hey, this is what I want you to, this is what I want this doll to look like, right? And it goes, got you. And then it holds that image until you tell it what else to put on. When you want to receive a touch signal, you flip those pins to inputs, and then you actually measure the, yeah, you can see the stuff coming off the board there. That's not actually coming off the board itself. It's coming from around the board, but it is what it is. It's over there. We're fine. The thing that they did in that library, though, was to read the touch input. They, quite rightfully, and as you needed to, shifted those pins from output pins to input pins, read their status, did all the stuff, and then didn't set them back to output pins. So the second you would read a touch value, it would crash the whole screen, because then you're trying to send outputs up input pins and it made everything break. And we are on our way up. So we actually should be reflowing in a moment here. We are about 3/4 of the way up our temperature curve. So you should see that solder get a little loose, and it should start reflowing and should get really shiny and start moving in any moment now. There you go. There's the reflow. You can start seeing some of the metal going and some of the components starting to float. And I'm just going to be over here for a moment, just taking a look at how everything is sitting, which I know that we already have one that's not sitting where it should. Fixed one. Looks like otherwise we look like we're actually doing really well. Just gonna give that guy a little nudge, make sure that's all fine. All right, so we are through our flowing portion, and currently now it's boiling off all the remaining flux to make sure that absolutely everything is really nice and clean. Make sure that all of those joints are really solid, so you can actually see the metal kind of shimmering and shining there. I don't see any bridges. I don't see any issues like that. So this is actually looking like it's gone really, really, really well. All right, and we are on the downslope now. All right, now we just need to let that cool a little bit. That timer works. Sorry, when you said, oh good, that timer works, I'm like, yeah, it does. I tested it to death to make sure it did. No, you're talking about the Nightbot timer, not the timer that just soldered that entire board. Oh, silliness. Alright, so we're gonna let this come down in temperature a bit. It's current, so you want to make sure that you cool it. You want to cool it relatively quick, but you don't want to crash your components. I think that with this particular board, I'm actually going to move it sooner than later. I did not think about a spot to put this, so we are going to put it there. All right. So this board, as you can imagine, is screaming hot. It is called Lioran Board 2. Like that. And I should actually add a link to that in my gear list. Should probably go in and do that. Actually, you know what? I can do that while I wait for. I can do that while I do. Ba-ba-bum. Lioran board 2 / Sammy, and we will send a link to that. Put that link there, and I will write a description for that later, but the link is now in. Thank you so much, Grace, for getting that. Much appreciated. It's really not bad. I was terrified of it for ages, and honestly, to set up everything I did, it took me like 2-3 hours. It really wasn't bad. I see the printer cam has the zoomies again. Oh, Toby. Oh, my Tobes. Oh, bud. Alright, so the board's still pretty hot, but the solder joints are all good. So, what we're going to do is we're going to start evaluating. So, what you can see now, if I kind of darken up some of the scene here, you can actually see the seam, the joins now. Whoop, there we go. So this is super clean. You can see that this one's probably a little bigger than it should be, but I mean, Googling Sammy brought nothing up. He was like, restaurant, depot. Yeah, exactly, right? So we're going to go through and probe all of this, but you can see that our components are well attached. You can see that we have some really lovely looking, consistent, clean solder marks. All of our components are nicely aligned. You can see that they're all nice and square and parallel to each other. And the board is now safe to handle, so we're good. So I'm just going to actually put this up to my face now so I can see what's going on. I am very pleased about that. That went incredibly well. Nick, welcome in, friend. How you doing today? Hope all is well with you. Hope you're having an alright day, and that's gonna break later. Alright. Cool. I am very pleased with that. Alright. We're going to flip this over. And now we're going to do the absolute opposite of what we just did. We're going to do hand-soldered surface mount components. And you'll see the difference in kind of... It's a week of surviving. You know, that's a win as far as I'm concerned. I can go over there. All right. Oh, buddy. Hey, bud. Hey, Toby. Hi. Here you go, bud. This is now the Scritching Toby channel. I mean, it always was, but we're just truly embracing our identity now. Here you go, Jobs. Hello, bud. Yeah. Oh, buddy. Look at that face, right? The puddle tobes with the big ol' fangs. Those are teeth that have a kill count. Very thin. Yeah, bud. And you can scratch him right here. You can scratch him right here. Along here. And you can feel Toby's ears because they're very soft. Poor neglected dog. Poor neglected dog. Like, look, there's a hand right there that's not petting him. Oh, buddy. Love you. All right. All right. So, now that we have gone through and soldered our board the fancy way, we're going to solder our board the not fancy way. So we have a couple of components that are on the back side. Now, technically you can do double-sided reflow. I don't have the tools for that. So, we're just going to manually put these components on, which is fine. It's not an issue at all. It's easy enough to do. 1, 2, 3, 4. Alright, toss our components down. So, there's a bunch of different ways of doing this. Some more correct than others. And I'll be interested to see how things go. If I can find my scouring pad. There it is. So right now, what I'm running into is the soldering iron tip is kind of super oxidized. Can you sit any closer, Tobes? So one thing you'll notice is when the tip is super oxidized, it's plenty hot. It doesn't have the capability of transferring heat into in there. So, a couple of things you can do. So you can kind of stick at it, get the scrub the tip off, all the other da-da-da-da-das. Also, something you can do that works quite well is use some solder paste. If you already have it in your workflow, solder paste is really fantastic for this exact purpose. What, cleaning your tip? All those other good things? You're showing great restraint. Alright. Just about back. This very much sat for a while. When it shouldn't have. Sat for a while on last time. So now you can see the nice and shiny and melt solder nice and easily now. Can I help you? Hi. Hi, Tobes. So, oh, and under the table he goes. My buddy, what you doing down there, Tobes? What you doing, bud? Normally, this is what he does at Carrot's desk. But, if I'm not mistaken, Carrot's currently in a meeting. And it's, oh my Tobes. Oh my buddy. I'm just gonna drop that in animal photos real quick. Because it's nothing but Tobes looking poor, neglected, and unloved. Okay, bud. Is that where you're gonna be? You're just gonna sit under my desk while I do some soldering? Yep. He does apparently want to be cozy. So, what we're dealing with is this package here. That's the item we're dealing with, and I'm trying to remember, I think it's SOP 23 or something of that nature. SOP 223. There we go. Hey, no, this is a voltage regulator. An AMS 1117 5-volt voltage regulator. So that's going to go there. Now, something that's nice about this particular voltage regulator, and generally most of them, I mean, on this one, I kind of made a smiley face. I literally put a smiley face on the RC one. Carrot, Tobes is under my desk. Carrot, look at your dog. Look at your dog, Carrot. He has a pillow. He has like 4 beds through the house. He already has everything. He just decides not to use it. There you go, bud. Okay? Okay, buddy? Tobes is watching you. Alright, so something that's nice about this particular circuit is this middle pin and the this pin on the top are actually identical. Sometimes they are... sometimes it's not connected and such. However, in this instance they are, so we can actually make it as part of it. However, when you're soldering this particular package, my suggestion is come into this pad first, because then you can float the component on it, similar to what we've done with the other one. And you can see how that floated. And before that melts, we can get that nice and aligned. And you'll see we have one of the 2 voltage regulators pinned in place. The other 3 tabs are just a matter of putting some solder on them. So there we go. Those are those 2 set in place. Now, what I tend to find is easiest for smaller components is to go along and wet one pad. And again, this is not technically proper, because technically this way you don't actually end up with flux on a particular side. But if I reflow that, it allows me to float that capacitor in there, and then I can actually reflow the ones, I can flow the one side and then come back and add additional solder and flux to the other side. Trying to do my best to make this nice and clean surface mount soldering, but at a certain point there's only so much you can do when you're working by hand. Alright, so now we have all of these components tagged in place. In this instance, this one's actually well connected on that part, but we're now going to go along, flow in these tabs. We're going to flow in the empty side of these capacitors, and then we're going to come back with a little bit more solder with a tiny bit of flux on the side that we just used to hold it down. Hands are shaking just watching me, right? So this is all about bracing. So right now, my hand is sitting against there. I'm braced here, here, elbow, arm. My elbow is actually on my armrest. So all I have is just the pencil mark, just the pencil line muscles. That's it. And then on the other side, I'll do the same thing. I'll brace with fingertips against the table and other such of that nature. Finding yourself a stable working position is realistically what will allow you to be able to do this kind of work. So same as before, same as regular through-hole soldering, you need to make sure both the pad and the pin are warm. Put your solder on, give it a second to let the fluxes boil off. You don't need a ton of solder. Like this? For me, yeah. That's how I hold pencils, yeah. Yeah, this is my pencil grip. I mean, this is, you know, objectively the right way to hold a pencil, right? Everyone else is wrong. I mean, don't use me as a measure of whether or not you're weird. That's probably not a great, probably not a great option. There you go, Tobes. Apparently he has decided being under my table is not advantageous anymore, and he has left. You can hold it different, right? Now, something you do need to be mindful of with these smaller components is you're applying enough heat to hit the pad and the terminal, but it can also transmit enough heat through the component to melt the other side. So you got to make sure that you work fairly quickly on these smaller components. The smaller the component, the shorter the amount of time you have before it actually becomes a problem. We're going to turn our board around, and we're going to deal with the dodgy solder points that we created on the far side. Put a little flux in them, because we just use those to hold our connections down. Now, did I need to go back and do these? No. No, definitely not, especially not in this application. This application, way more than enough to just leave it like that. Comment, welcome in. Good time zone to you. How's it going? We are working on our little board today. We just finished doing all of our surface mount components, which is super fun, super exciting, and I'm very pleased with how that's all going so far. Now, I want to say, I actually taught a friend how to solder on the Arduino the other day. That was kind of fun. And where did I put those? Remember, they were somewhere weird. And apparently I didn't keep the one I had already out, so I need to go track down another one. I know I have more than one. Ba, 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 ba. Come on. Where are you? Right there. There you are. I'm doing very well, thank you. Apart from, you know, total and utter burnout right now, but that's okay. We're gonna get through it. It's not too long before things calm down for me, so that's annoying. I had desoldered the other one. Give me 2 minutes. I need to go grab my when's my last midterm? Monday. Monday is my last midterm. So I had one this morning. I've got Monday midterm. Tuesday I had both a project and a major report due, but I got the project done, and then the project got a week-long extension. But yeah, my final my PR5, so the second to last capstone report, my 5th progress report, there's 5 of them, and then we have our final report for capstone. That is due on Tuesday, which has to have our full CAD documentation, engineering decisions, calculations, simulations, all that stuff. Already went through, validated all of the electronics in there. So went through, already put in all my calculations, the trace width sorting, the circuit diagrams, all that other nonsense. Yeah, so I've got to get through that midterm. Robotics and automation, which is just a real nasty course. It's all about inverse and forward kinematics, and it's like 6x6 matrices of coordinates and rotations and transformations, and it's terrible stuff. And then Wednesday morning, I've got my mechatronics project demonstration number 2, where we need to be able to get our little vehicle to autonomous and navigate a maze, pick up a soil sample, and return back to the start, when last time we couldn't get to the soil sample. So we still need to do a bunch of development and repair and troubleshooting and such on that side. Part of that was the fact that the motor driver shield junked out on us the day before the final test. So I had to completely rebuild the entire circuit the night before the night before we had to test at 8 a.m. That was the day of the reverse career fair. It was up till 4 a.m. that day doing that rebuild, and then finishing up packaging stuff for reverse career fair. But reverse career fair might actually have turned out to be a really good thing. I've got one interview next Friday with one really lovely company, and I have a meeting with the operations manager from the people that wanted to see the rat car. So I've got a meeting to go discuss projects and employment, and camera has the zooms again. Yeah, I'm very excited. Yeah, we is correct. It's not in the right area where I want to actually work, but the job is really interesting, and at least at the exact moment, I am going to take what I can, and I'm willing to entertain any meetings, offers, considerations, or discussions that anybody wants to have with me. Right? Like, even if it's just a matter of sitting down with somebody and going, all right, look at my resume. What don't you like about it? All right, fantastic. You know? All right, give me very good, at least good interview practice, right? Interviewing's never been something I really have a terribly hard time with, but, you know, that's a whole thing. All right, give me 2 minutes. I gotta grab my solder sucker from my backpack upstairs. Be right back. Hello, I am back. I'm really hoping that, I really am hoping that my resume has kind of worked against me while I've been working for, basically when I'm trying to find co-op and internship and stuff like that. I've actually had it basically full on put out was, the fact that I had too much experience. Like, I've actually got life and work and project experience and everything like that, and a lot of companies are looking for somebody to push spreadsheets around and give them a chance to actually do something, right? So it kind of becomes that thing of like, I'm really hoping now that it's actually like, hey, we're trying to hire somebody, that, by the way, I am still very much using the tool roll we made on stream a while back. Still very much using that. And it is no end of entertainment to pretty much anybody who ends up seeing it. And I have picked up an even stronger reputation of being the person who has everything with them. Last interview, I would not have hired myself. I only ended up there because my prof worked there and got to know me. You know, who you know is sometimes more important than what you know, and sometimes it also just comes down to somebody knowing that you might not interview well, but you really know what you're talking about. Which with every conversation I've had on a technical front with you, Dermo, I know that is the case. Is that you really do know what you're talking about, even if you might not interview the best. And 100 interviews, being a contractor for a while, you know, when things could end, still don't like it. Yeah, right? Come on. There we go. Alright, so what we just had to do was, currently, this guy is going to be sitting this way, which basically means that we needed to have we needed to change the orientation, because this was set with some 90-degree headers, which are meant to have it stab into something this way, where we need to have it lay flat. Yeah, I don't actually know what you do, Nick, but I can appreciate the whole contractor lifestyle. It's a whole mood. Okay, I need this right here, actually. I need 3 pins of that. So this is what we normally do, is through-hole soldering, which is put a pin through a hole, and then you're soldering that pin to the hole. Ooh, that's not my best solder joint ever, but that's okay. I think I'm alright with that. Now, I do know I have an interference with the 2 components that we're dealing with right now. Right, I needed to ground those 2 pins together. That's correct. Yeah, because that goes out. It's going. What? I forgot so much now and only have surface knowledge of most things and no experience at where I'd want to go, so not the best starting point. I feel like you probably end up doing better than you expect, but... Oh, okay, no, it doesn't connect there. It passes through the middle, over and up to there, which is 2. Fourth pin in, which is the 5-volt pin. I don't know why I did things that way, but okay. Whenever I interview people, I'd always get massive feelings of inadequacy, like, wow, this person's so much better, why did I get hired? Work in cybersecurity. Left engineering after only a few years. Now I only design IT systems. Look for threats, pattern intel, counter intel. That's a real big brain trade you got there, Nick. The best I could sell is I'm good in learning quick. Honestly, Dermo, that is what I built my entire career on. That it. Top to bottom, my career, what am I good at? Learning quick and unlearning just as quick. Because learning things is important. Unlearning them is also important when things move quick and you need to forget how the old thing was. Yeah, no, that's a skill in itself, honestly, and most people are really terrible at it. Don't sell yourself short on that one. Yeah, don't sell yourself short on that skill, my friend. That is a fantastic skill to have. I realize that this is probably not the best camera angle for you anymore. Only. Right, like cybersecurity as a whole, one of those terrifyingly complicated trades that everybody seems to think that they understand what's going on, but realistically, basically nobody actually does, except for like 5 people who designed all of the systems. The problems, connections, the broader view. I know that those are both some good qualifications. Feel like miss so much. Honestly, Dermo, you and I are the same person. Right, like I am really good at the really big picture and the really nitty gritty picture. I kind of am terrible in that kind of middle zone of like I can solve a problem, no issue, and I can keep a project moving entirely, but like, I don't know, there's that kind of middle ground where you're not at the project level and you're not at the detail level, and that's kind of where I end up missing some stuff. That wasn't the smartest thing I've ever done. Alright, time to unsolder that. Just... I find it kind of funny talking about how I can sometimes miss the middle picture. That's literally what I just did. Literally just did exactly what I just said, how I can sometimes miss the middle picture. That's exactly what just happened. Come on. And the soldering tip is getting a little tired, which, I mean, I can't blame it. It's seeing quite literally thousands of connections. But I just need it to kind of come back online here for me. What's the sad face for, Julie? Julie and Carrot are both smart. Like, the thing is it's very different skill sets, right? Like, I've met very many very, very, very smart people in my life who couldn't talk their way out of a freaking paper bag. And I have also met people who don't have any technical understanding of anything at all, but understand people and the way things interconnect and the human side of all of it. And they do a phenomenal job as well. And I know we're currently in a society that very much fetishizes like engineers and engineering and such, but that does not take away the value of what everybody else is bringing to the table. Yeah. Oh, absolutely. I mean, that's the reality, is like if you had competent, like, the number of times I've designed something for myself fully knowing that like the UI wasn't perfect, but also fully knowing that the only person that would ever use it was me. Because like my little solder plate there, for instance, if I was gonna market that thing, never in a million years would I design the I didn't. I actually I apologize, Julie. I clicked the wrong I clicked the wrong comment. I mean, I meant to delete both now that I see Julie's, but you know, I meant to delete Carrot's. I apologize, Julie. I now understand why the sad face. Look, I'm doing what I can right now. That's all I can say. It's the best I can do. Oh, I can definitely mod the mods. Oh, I can. I just clicked the wrong message, that's all. I just missed the the target, that's all. Yep. I have the buttons to just delete other people. There is not a single person in this chat that can, No degree is totally fine. Not an issue at all. I did not have a degree. I still don't technically have a degree yet. I spent most of my career without a degree. All jobs are worthy, right? That's the thing, is if there wasn't a demand for it, there wouldn't be a job. So, by the virtue of the job existing, clearly it is a something that is in demand. Okay. Now let's do things in the smart way. So what I screwed up is I soldered on the humidity sensor before I put the Arduino in, and I couldn't get... I wasn't going to be able to get to all the pins. And not that I actually needed all of the pins. I needed access to a couple of the pins that were going to be covered. There is. Yes, there is, Zan. It may not be where you are currently, but there is a demand for it. All right. So whenever soldering a board with a whole lot of pins like this, you always want to make sure you do your first pin, then evaluate, take a look, square everything up, make sure you're happy, and then you can do one on the far side and roll your way through. People are starting to clue in, yeah. I don't know, what are you at these days, Zan? Must be a Zan. Unfortunately, it's a very, very tight job description. You're going to get a lot of unqualified applicants. How many followers are you at right now, Zan? I know you've been seeing a bunch of growth lately, but just wondering where you're at. $7.79. Jeez, look at you go. That is awesome. I mean, it's hilarious when those numbers start going up. Like, even us sitting here with just under 400 followers, I honestly saw the big burst from when the dinos came in, and that was about it. All I was expecting. Like, when everybody kind of showed up right when I first started streaming, it's like, oh well, you know, 100 some odd, great, that's awesome. I figured that I would just kind of hang out there forever. I get that, Dermo. I really do. I spend half my time at uni arguing with people who think they know better, that are blatantly wrong. And like, I'm not the person who thinks that I know everything, but I will say that when something isn't right, I'm very quick to be like, no, we're gonna make this correct. And then people get all ego about it, and it's a whole thing. I've yet to make a stand like that and actually be wrong about it, though. It's just people tend to be used to having 19-year-olds that don't challenge them on anything. rather than somebody who really doesn't care what qualifications you think you have. I am paying you to teach me. Now, you're going to do it right. Yeah, book learning is rough. Honestly, I think the first 3 months out of your first job is always going to be more valuable than pretty much all of university, though, because that's 3 months of 8 hours a day in a particular field versus, you know, 1 semester of taking 6 courses across disparate fields, you know? Like, it only makes sense that you would learn more in the concentrated setting where you're actually applying the knowledge rather than trying to pick up the knowledge to understand what you're looking at. Wow, these ones are terrible. On to a different pair. Dropped out because my first 2 years of uni, all the courses in my major were so boring. Profs also cared more about selling their books than teaching. Oof. Yeah, that's disgusting. I have not bought a single textbook since first year. Need to chop off all of the header pins. Come on. They're forced to teach at least one undergrad to keep their research grants. They're clearly researchers and not teachers. My kinematics and my structures prof, which were the same person. The prof that taught me structures and properties of materials and kinematics and dynamics of machines. That was their thing. They were very much a research prof and did not care at all about students, teaching, or otherwise. And COVID was the best thing ever for them because it allowed them on the first day of class to upload the entire course worth of lectures as videos that were really, really, really poorly put together. And then basically not answer anybody's email the rest of the semester. Ooh. Ooh. Yeah, that's not okay. That's really not okay. Yeah, honestly, that and again, that's where I end up in fights with people is like, I 10,000% would have reported that to the student union, to the faculty, to the department chair, to the president, to the vice president, to the local newspaper, whatever I needed to do to have somebody get angry with me. Yeah, no, I 100% would have lit people up for that. Chose to sleep in and have more fun instead. I always laugh because other faculties, they talk about, you know, going to parties and all that and everything like that. And they always say, like, whenever the engineers show up, they don't show up very often except for, you know, there's a couple of engineers that show up to everything. But, like, most engineering students don't go to a lot of parties. But apparently we've got a reputation of when the engineering students show up for a party, everyone else is drinking to have a good time. The engineers are drinking like it's the end of the world. And you know, I get that. I really do. I'm gonna leave some melting solder on there. Alright, so we have that, we have that, we have that. These guys can get cropped. I'm gonna grab our little 9-volt battery clip. Garrett and I are currently trying our best to have some new dice ready to drop in the shop for Streamfest. So we'll see if that ends up coming to pass. But we're trying. We're trying. So one thing that is nice. So if you can't remember how you wired something, let's focus this in. Now, I need to hook up my battery connection to this board. Now, somebody like Dermo would almost definitely know exactly how this gets connected up, because they know what I'm about to tell you. So, if I were to look at these two things without looking at the circuit diagram or looking at anything else, I can tell you that this is my negative and this is my positive. And the reason I can tell you that is because of this nonsense here. You see these little crosses? That is thermal isolation from the ground plane. So you'll see that these connect up to this massive green area here. That's all copper. If I were to try and solder to this pin without these, and this just flooded right up to the edge of the pad, all of the heat would go from the pad and into this plane and get wicked away from the joint. The Mothman and the Potion, that's fantastic. That does fit incredibly well. I also feel like the Poggies emote would also go in there very well. But yeah, so this is what we call thermal isolation. So the entire idea here is to allow you to have proper electrical flow without issue. But nice land, Yazili. Very nicely done. Jeez. Allow proper electrical flow while still allowing to give a small thermal cross section to prevent your the heat from your soldering iron from just getting pulled away into the main plane. This one here is my positive line, and I can doubly check, especially with this particular circuit, is I know that that lead needs to go to my input capacitors for my voltage regulators. But otherwise, yes. So we almost have this board fully assembled, which is super exciting. And then what we can do is hook up a battery to it, and then flash a demo program on here, and see if things don't just explode. All right. So, before we connect the battery up to anything, what I'm going to do... Whoop, let's make sure those get back up there. It's a very pretty set of dice. Has some bubbles that I need to fix, but very pretty set regardless. I'm going to grab my multimeter, and I'm going to probe a couple... put a D20 on the back of your Moth logo for the dice. I tried. I actually did try. The problem is that it's already such a tiny amount of area that I did try a version of this. I might have it right here. Hold on. Oh, where are you? Did I just dump it in my bag? I think I might have just dumped it in my bag. Ah. One moment, please, while I pull out some dice. Yeah, so like this was one of the early versions that I tried. Which you can see was a moth with a 20 on the back of it. So I did try to do other stuff with it. Yeah, and that was probably about the best version I had with an actual number on it. And I tried a line work version, which was okay, but wasn't amazing. And then we ended up with this guy. Oh yeah, the Click Clacks. This one's great. Clever bought me this one. Is metal. I really like how this set turned out. This is my little electronics set, which has like resistors and LEDs and transistors and MOSFETs and all of the other fun stuff in there. A little bit of copper wire as well. Yep. Oof. This set made me laugh because this is a set I made for a specific character. And it was for a very, very creepy character that I'd made. Like real serial killer type. I came up with the idea of them a couple of days before playing, and this kind of like oily, metallic, meaty, fleshy kind of situation is exactly what I was going for. And they look almost dirty in the hand. They're really uncomfortable, and that's exactly what I was hoping for. Those are mostly Chessex. The Chessex dice are going to be eventually given to people over time. I don't regret having them in my bag. However, they don't. I can say with confidence that none of these dice have gotten rolled since we started making dice. Like, and don't get me wrong, there's a couple of really nice ones in there. Like, I really like this orange one. It's quite nice. I'm a big fan of the opaque and translucent combination, but the first sets of dice that I did actually were recasts of the Chessex dice. So like these guys. And we were really Rained, welcome in. You missed a whole bunch actually. I think we're about to do a final check and we got off task, but we were just talking about dice, and Grays had made a suggestion as far as a particular thing for the design of it, but I had a couple of iterations of what we had tried before going to the moth. See, you can't go on a detour if you were never on topic to start with. So Rain, this is what you missed. The Drunk Beavers got their stuff together and delivered the board. And we have just finished soldering all the components to it. So I was just about to hit it with my multimeter, do a couple of continuity checks to make sure that we're not going to blow anything up. And then we were going to plug it in. I remember that being a thing on a screen, right? That's honestly one of my favorite things. It's always so exciting. All right, so. All right. We're going to start on the back side because obviously we need to make sure that we are getting there we go. There it is. Gotcha. Okay. That. Not shorted there. Not shorted to any of those. Not shorted to any of those. Oh, I did connect that up to VN, didn't I? That's fine. VN, it can be connected to. That's not an issue. All right. So, then we're going to double check this. I think we're good on that front. So that's where that one goes, and we don't have any issues there. We're going to check a couple of specific. Come on. Make good contact. Yep. All right. Cool, cool, cool. All right. I like that. All right, cool. So, what we're gonna do. I'm gonna grab a battery. Oh, that's triple A's. That's not a 9-volt. Where my 9 volts should be? Dice. Why? Why are there dice? Okay. That's a thing, I guess. Sure. Sure. Dice battery, apparently. There we go. Funny thing is, the overall code for this project actually isn't all that complicated, but we are running down on stream time here, and I don't have a ton of a lot of time outside of. So if this works, these LEDs here should turn on, and we shouldn't see any smoke or hear bangs. All right, we got LEDs on, and we have no LEDs on, which is good. That's what we want. That's what we want. Alrighty. So, now we need to grab a cable to program said Arduino. Do I have a cable up here already? Do I need to grab one? That's the oscilloscope probe. That's a power cable. That's a thing. Nope, nope. And we'll start with this. Why energized for a 9-volt battery should be. Yeah. I saw the last YouTube video, Slow-Mo guys with Electro Boom. I haven't watched that video yet. However, if it was Electro Boom and Slow-Mo guys, I would assume that there should be a a panic button somewhere on there. But that's just me. All right, so we are JC, welcome in. How you doing this evening? We are just getting ready to... Yep, come on. I'm gonna try this. Spent all day yesterday fixing stream settings. Nice! That is fantastic. Find data pin. I need to remember what my data pin is. So we're gonna go open recent. We're gonna go over to our little temperature amulet. We're gonna go take a look at what our data pin is, and then we're gonna try shoving some code onto it. D3 and D4. Okay. So D3, and there are 10 LEDs on there. And we are uploading to an Arduino Nano on port... let's find out. COM1, COM8. Which one disconnects? COM8. That's what I thought. All right. 8, that. Well, we're about to find out together if this works. Oh, error compiling for Arduino board. Now, the question is this an Arduino Nano problem? Or is this a Arduino... Okay, no, this isn't just a... This is a problem with the... Okay, cool. Cool. Need to go figure out what's going on with my libraries. 1 second. Update that library, so that should be correct. That should give us the ability to compile that. Cool. Now let's put that on the appropriate board and upload. And if all works well, the outside ring of LEDs should turn on in a second. Having an issue with the uploading. Da, da, da. Come on, you can do it. I'd say I believe in you, but I also don't want to lie, so... Come on, you can do it. Just not going, eh? Okay. Try reconnecting that. Alright. Is this a Pro or a Pro? Is this a Nano or a Pro Nano? Well, we're gonna stick with this for now and see. Alright, maybe we go with a simpler example first. Nano Com 8. Go. Error occurred while uploading the sketch. Okay. So maybe I just need to grab a different board. Let's try. Error occurred while uploading the sketch. Okay. Arduino Nano. I swear this is the Nano. Oh wait, hold on. Oh, hey! Ha ha ha! I think that's all this program is supposed to do. Hold on. Let me see, is this supposed to blink all of them or just blink one? LED 0, CRB, Z, turn it off and on. Okay, so that is working. So let's go to this fancy one and see if I can get the fancy one to go. Can we do the fancy one? Why does it not want to upload? Why is fancy one not like uploading? I want to do the fancy thing. Maybe that one's using something weird that the other one isn't. Let's do this. Number LEDs, 10. Nope, data pin 3, thank you. Error occurred while uploading the sketch. What is going on? LED version 3.0 for whatever, such and such and such. Alright, let's try doing something real quick. We're gonna do something a little fancy. Into our libraries, and we're gonna go delete the actual library folder. And close all the files related to it. Alright, we're going to close Arduino IDE. We're going to restart the Arduino IDE. We have a blinky LED though. However, I cannot say how... It's always hilarious how excited you can get about an LED blinking. Alright, so that is not there. Alright. Go back in here. Oh no, it's about to explode! Ah! Right? Sure, let's try this library instead. We're gonna use the library from the people that made the Adafruit NeoPixel RGB strand test. 3, 10, Nano Com 8, go. Something's going on here, and I'm not sure what it is. I don't think this is technically the right example for what I'm trying to do. However, stuff that. God, I gotta fix that. Why are you not uploading? That's curious. Because I should be able to... I shouldn't need the 9-volt battery connected. But for some reason, the 9-volt battery is what's actually giving me power. I should be able to power just the... Interesting. It's curious. Okay. Okay, fix that. Might change the bootloader, we'll see. Okay, we're getting errors from this. Whoa, there it is. Woo! Look at that. It's so colorful. It's so pretty. Ooh. And one of them isn't working, unless I have the wrong sequence. That's the last one. So hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did tell it 10, but did it take 10? Let's just quickly see. If I push 11 on there and re-upload, an error occurred uploading the sketch. Error while uploading the sketch. Why? I don't get it. Alright, welcome in. How you doing today? I'm very confused. I don't know if the LED is a dud. I'm having a hard time flashing programs to this thing right now. So I'm trying to see the fact that it's the last one in the series, because this is LED 0 and it goes all the way around to LED 9. The fact that it's the last one in the series makes me wonder if it's something in the software, just not counted, just an off by 1 error. But for some reason, this is just not uploading to that properly. Let me. Whoop. That's my big guess. I'm gonna grab a different USB cable and see if that one's the problem. Should have one here. Yep. I'm sorry, I need to pull this off screen because this cable does not sound like me a few hours earlier. Fair enough. What I'm really confused by is the fact that the reset button doesn't work. Like, the reset button resets the board, but it's not resetting the USB connection, which is odd. However, that's running everything off of the USB, so that's even more concerning. Very confused by that. Confusion intensifies. I managed to get this to push to the board once. I'm trying to figure out why it won't go now. It's not giving me an error message, is the problem. Did I not have verbose information turned on? 1 second. There it is. There's my issues. Okay, why? Can't open device. COM8. Okay, so there's half of our problem. Now the question is why? If I flip over here, you should be able to see what I am fighting with. If I go to there. This is what I'm fighting with right now. Just trying to figure out why. So all the compiling went fine, but it's not able to reset the COM port for some reason. And normally in this instance, I would disconnect the board from the rest of the circuit, because I've had that happen before where the circuit has given me issues with respect to uploading everything, but I don't really have let's try that one. Okay. How's it going? EVR 109. That's a different programmer than it should be using, but that's okay. No permission. chmod plus overwrite the USB driver? Is that what I'm reading correctly? Got new art supplies, books, and 2 Dr. Plague squishable. That is fantastic. Love that. Alright, let's try this again. Let's try uploading while holding this. It's curious that it's not sudo kill all. I like my my file system commands have always been a little dodgy. This is the Arduino Nano. I thought this is the Pro Nano though. See, normally when this kind of thing happens, it's usually something just setting read-write permissions for all user to the USB socket. Oh, fair enough. 1 second. What's my... No, that's 1, 2 are my oops, USB pins. Okay. 1, 2 is the USB pins, not that. Alright. D3 is what I'm connected to. D4 is for the other half. I don't think I'm connected up to anything that would give me problems when it comes to the USB drive. That's temp out, that's humidity out. That is... Whoop, that's not what I wanted. Oops. I want to change what side I was looking at. That's connected to there and there. Okay. Well, let's try manually resetting. Ba-ba-ba. This guy should be... Omega 328P. Let me go see if I just don't have the right driver for this thing or something. Let's see. Okay. So it is the CH340 driver. That's what I thought. I'm pretty sure I have the CH340 driver. But let's go grab it again anyways, because that's fine. It gets corrupted every now and then, so that's not an issue. Open this, uninstall, install. Successfully pre-installed in advance. Thanks for the lurk, Kitty. Much appreciated. Did I hit the finish button? Oh, apparently I did. Don't know how that happened, but okay. Sure. Oh, why you gotta be this way? Let's see. Just looking into the help forums. Is there a timeout for when you can re-enter drops? Go for it. To your heart's content. the old bootloader. Nope. Alright. Well, I think at this point we have firmly ruled out that it's a USB cable issue. So I'm going to put on the USB cable that is actually long enough to go back into frame. Although I think there actually is an issue with this USB cable, because that doesn't... One powers everything, one doesn't. So, let's see. That's another really short one. Here. Another really short one, but screw it, it's brand new. So let's explore that for a minute. I have suspicions that we might have robomothed for a second there, but I'm not sure. Oh, it looks like that might have actually worked. Come on, let's just double check. Put that on pin 4. I just have a bad connection to... Oh, that's why that one's not working, because it's wired backwards. Well, I know why that one wasn't working, and apparently it was still, after all of that, a USB issue. I don't know why, I don't know how, but that's okay. And I also know why that one LED isn't working. However, look at this. Look, it's so pretty and colorful. The issue is that this LED is wired backwards. So, what we're going to have to do, because this is surface mount, because this is all of that other fun nonsense, we actually need to get into part of the tool set that I haven't shown anybody on stream yet. Which is this guy. It's a small enough nozzle. There we go. That's the right temperature. Let's get the airflow right. And the lights are going to get flickery. I'm sorry. There's nothing I can do about that. It is what it is. So this is the other way that you can rework. You can work with surface mount. So we did the reflow plate. We did hand solder. This is a hot air gun. The whole idea of which is to basically just melt solder on the surface using hot air. Alright, and we can then go this way. Well, we'll see if that LED still works. I think I overheated the package, but that's okay. Oh no, no cutting traces. So now we should. Actually, that's programmed to light the other Apparently this is set to program the inside, to run the inside traces. So that's fine. I'm going to program it to run the outside real quick. Reprogram that. And as a satisfying conclusion for tonight's stream, we have not validated the humidity sensor. However, we have now confirmed that all of our LEDs are working and that everything is pretty and that this is going to be super fantastic to look at. Lamp. So there we go. We have a fantastically colorful and flashy little board here. I'm actually really quite pleased with this right now. This is the first time I've worked with this this particular component, and that was very easy. So I'm really pleased with that. Those are definitely going in other projects going forward, 100%. So what we've got left to work on for this is getting our humidity and temperature sensor working, and writing the code that relates humidity and temperature to our particular panels. And now after the fact, I'm kind of wishing that I put a button on here that I'd be able to just turn this into a party amulet, but so be it. Lamp. Lamp. We are lamping. So yeah, there we go. That is functional. I'm just gonna quickly see if I can very easily. Oh, that's a big program. Do I really want to do that for both? Is there an easy way to define this for both? No, there is not. There is not a super easy way to... Geez, these are only a fifth total brightness, which is kind of silly. Just glue a button on it. Exactly. That's how this works. That's how it works. Yeah, that's really satisfying to watch. And make a little rave cave here. I'm just trying to see if there's a really fast way that I can run for each run through. Yes. Pixels. That okay, cool. This one I can double up. All right, cool. This one I can double up fairly quick. I don't think this one's going to be as flashy. However, that is okay. I just want to have both running at the same time, doing funny stuff. That and that. You have to find... gotta copy this piece as well. If I flip over to that one, you should be able to see what I'm doing. Lost me to the lamp, right? Just one more light. One more light. Must be brighter. Alright, so we are going to just grab all of that. And paste down second. 2. 2. And the 2. And the 2. think expected a 4. Oh, that's why, because this one is... Oh, actually, I don't need to have a second for statement here. Don't need that second for statement at all. All right, that should work. I should be able to bring this off screen. Now this one, I believe, is just going to run a single color through. Ooh, yes. Lamp. Give lamp. More lamp. Out of the lamp. Lamp. Well, before you head off, there you go. Here is our victory for the night. All of our LEDs are working. And the way I have it set up, this is resetting after each one, but this one isn't. So that's actually intentional. Yeah, this is super exciting. I'm really pleased by that. Super fun. I appreciate everybody hanging out with me this evening. One more finished? Absolutely. Gonna let you stare at the lamp for a moment. While I see who's going right now. Look at the blinky. Can we get a ting of completion? I still need a proper thing for that, unfortunately. I can... Is that good enough? Accepted. Fantastic. All right, we're gonna go say hi to a tome of completion. If you want more lamp. We're gonna go say hi to a friend of the channel. We're gonna go say hi to the Witch and Smith. They've been going for about an hour. I think they're doing some D&D map making at the exact moment, and so we're gonna head on over there and say hello. I would enjoy some sort of flim-flam machine. Oh, stop scrolling around on me. That ends... Some sort of flim-flam machine that ends at a ting. I think we could probably do that. Alright. Thank you, everybody, for hanging out. Artist Explores the World. Thank you so much for the raid and for hanging out with us for the rest of the evening. Very much appreciated. Thanks for being here. Thanks for making my Thursday a little bit better. We are not streaming on Saturday. We normally would be, but we are not streaming on Saturday. There is Streamfest. Carrot is going to be streaming at 11 a.m. as part of Streamfest. You do not want to miss that. I know what she's going to be doing, and it is going to be hilarious and ridiculous. So, follow the Carrot. Make sure you set your notifications and all that good stuff. We'll be sending out a note. But otherwise, I will see you next Thursday at 5 p.m. Eastern Time. Have a great evening.